So we need to find vector p in component form to do this easily, and q in component form to make this easier as well. So I'm going to start by finding vector p in its component form. And for this one, which will be a little bit different than how we do q, I can say that vector p I can represent by its magnitude times its direction. So I don't know what its direction is. I don't know u hat p is what I'm going to call it here. I do know the magnitude of p, though, because it was given to us. P has a magnitude of 100 pounds. So I can find vector p if I can find this u hat p term, the direction of vector p. And that's going to depend, again, on how was the vector presented to us. In this case, for vector p, we're told the angle it makes with the positive x, the negative y, and the positive z axes. So we can use that information to assemble u hat p. When we're presented with information in this format, we can take the cosine of the angle it makes with all three positive axes, and those will be the I, j, and k components of this unit vector, corresponding to the x, y, and z axes. So for example, if we look at the angle that vector p makes with the x-axis, 60 degrees, that means that for this unit vector, the I component will be cosine 60. And then we'll find the fraction or the decimal in a minute here. But cosine 60 is the I component for u hat, the direction of p. We add to that the cosine of the angle it makes with the positive y-axis. In this case, we're told that it makes a 45-degree angle with the negative y-axis. But for this, we need to know what it makes with the positive y-axis. In that case, we want to use the supplement of 145 or 135. So it makes a 135-degree angle with the positive y-axis. And then finally, for the k component, it makes a 60-degree angle with the z, which means that the k component will be cosine 60k. These all have nice fractions that go with them. So if I can write it as a convenient fraction, I tend to. So that's 1/2 I minus root 2 over 2j plus 1/2 k. And one thing we want to check, especially early on when we're first dealing with unit vectors must have a magnitude of 1 for it to be a unit vector. So we can, at least for now, be checking our unit vectors to make sure that's true. We find the magnitude in 3D the same way we did in 2D, the square root of the sum of the squares of each of the components. So in this case, 1/2 squared is a quarter. Root 2 over 2 squared is going to be 2 over 4. And 1/2 squared is 1 over 4. So the magnitude we get is square root of 4 over 4, or 1, which means that the magnitude of this is indeed 1. And we do want to make sure that's the case for now. We probably want to check that extra step just to make sure that later on we don't make a division error or some sort of calculator error. So this unit vector does indeed have a magnitude of 1. So the last step is I want to find vector p in component form. I know that its magnitude is 100. I just found u hat p. So I multiply this scalar by this vector. And to do that, I'm really just distributing the scalar into the components. So the 1/2 I gets multiplied by 100 and gives me 50i. 100 times negative root 2 over 2 gives me about negative 70.7j. And the 100 times the 1/2 k gives me plus 50k. And this is in pounds. All right, for q, we are presented with the angle it makes with the xz axis, plane, and then the angle that projection makes with the x-axis. All right, so kind of the instructions we could take if this were a robot arm of some sort is we would take the arm, rotate it 40 degrees, and then rotate it up 30 degrees. And then that would be the representation of our vector. So we want to convert those instructions, and if the arm were well, this is a force, but if it were a length, we could then find the ijk components that way. So we want to go from that method to ijk so it's compatible with what we're doing here. So the method we want to use for this presentation is we can see, if we look at this vector q, we can see that we can drop down the y-axis to the xz plane and then make a leg within the xz plane. So if we look here, we form a vertical triangle with a vertical right triangle. We know this angle, we know this is 90 degrees, and we know that the hypotenuse is 60 degrees. If we look at this other triangle that's left over, we know that this is parallel to the z-axis, this is parallel to x, which means that this is a right angle since x and z are orthogonal. We know this is 40 degrees, and we know that this leg is going to be shared with the other triangle. I'm sorry, this is actually the hypotenuse of this triangle is a leg of the first triangle. So we're going to be able to make two right triangles to get the information we need to see how much of q is in the y, how much is along the x, and how much is along the z directions. So I want to start by drawing that vertical triangle. So this view is if we were sitting on the xz plane and we were looking at this vertical triangle, this is what we would be seeing. It's 30 degrees, and we know already that the hypotenuse of this triangle is 60 pounds. This vertical leg of the triangle is completely, or is parallel to the y-axis, meaning that this is how much of q is in the y direction. And this leg is this dashed line here. This is the amount of q that lies in the xz plane. I'm going to call that qxz. It doesn't lie only in x, it doesn't lie only in z, it lies in some combination of the two. In this right triangle, I can solve for these legs because I have enough information between the hypotenuse and this angle here. So for example, if I use sine 30, that will be qy over 60, which means the amount of q that's in the y direction is going to be 30 pounds. Similarly, if I use cosine, the amount of q in the xz plane is going to be 52 pounds. So the y component I have done, I know that 30 pounds of q lies along just the y direction. The 52 pounds is going to be really a means to an end because now I have to make that second triangle, that lower triangle that lies in the xz plane, as another picture. Right, so here I'm standing on top of the y-axis looking down at the xz plane, and I'm seeing this triangle here. So this leg is how much is only along the x direction. This leg here is how much is only in the z direction. And then the hypotenuse of this triangle is the same as the leg of the first triangle. So this is also qxz, which from the previous step I know is 52 pounds. And I'm also told this is 40 degrees. So looking at my second triangle, I can find these two legs. So again, if I use sine 40 now, that's going to be my opposite of qz over my hypotenuse of 52. So the amount in the z direction is going to be 33.4 pounds. The adjacent is qx, and that's over 52. So the amount just in the x direction is going to be 39.8 pounds. So the amount just in the y just in the z, just in the x. So to form vector q, I need to assemble these three parts, but here's where I have to pay attention to the direction, and I'll get that by looking at my picture, or at the diagram. So in this case, if I'm at the origin, I want to see how do I go from the origin to the tip, or where q is pointing. So if I start at the origin, I have to go along the x direction. I'm going along the positive x direction. I have to go along the negative z direction. And then I have to go along the positive y direction to get to the end of point of q. So I can't just say it's these numbers. I have to make sure they have the correct sign attached to them. So again, starting at the origin, I go in the positive x direction. So I'm going to go positive 39.8 pounds in the I hat direction. At least the way that this is drawn. I then have to go in the negative z direction to get to this point. So this will be a minus 33.4 K. And then at that point, I have to go along the positive y-axis to get to the end of Q. So I'm going to go a positive 30J. And then I have Q in its component form. Right, so the last step now is we want to find the resultant of these two forces acting simultaneously. This is the easy part. We just add the like terms together. So 50I plus 39.8I is going to give us the 89.8I. Negative 70.7J plus 30J gives us negative 40.7J. And the 50K minus 33.4K gives us a positive 16.6K.